Hello, everyone. Welcome to lesson 3-2. Today we're going to be learning about statements, conditionals, and biconditionals. And we are here together on page 161. We have three learning goals for this lesson. Number one, to learn to write compound statements for conjunctions and disjunctions, and to determine the truth values of those statements. Number two, to identify the hypotheses and conclusions of conditional statements and write related conditionals to those statements. And number three, to write and analyze biconditional statements and determine the truth values of those biconditional statements. So a statement is any sentence that is either true or false, and we're going to use T and F throughout this lesson for those, but it can't be both. Truth value is the truth or falsity of a statement, and statements are often represented using a letter. A lot of times P and Q are those letters. If a statement is represented by P, then not P is the negation of that statement, and that means that it has the opposite meaning as well as the opposite truth value. So the negation of a statement P is not P, or you can see this symbol that we use here is what we call a tilde and then P. When you're putting two or more statements together and you join them with the word and or, that's what we call a compound statement. A compound statement using the word and is called a conjunction, and a conjunction is true when both statements that form it are true. A conjunction we see as P and Q or P and this caret symbol, Q. A compound statement that uses the word or is called a disjunction, and a disjunction is true if at least one of the statements is true. A disjunction is written as P or Q, and you can see that that caret is upside down between the P and the Q. A way to remember this might be that if you think of and or, which are in alphabetical order, then and is going to go with con, the prefix, and or is going to go with dis. So both of those are in alphabetical order when you think about which part of junction precedes it. So here we are on page 161 with example one, and we're asked to use the statements to write a compound statement for each conjunction and then find the truth values to explain, and then of course explain your reasoning. So statement P says the figure is a trapezoid. Q says the figure has four congruent sides. R says the figure has four right angles. So here we are going to join those statements together. So the first conjunction that we want here is P and R. P and R means that the statement P, which is the figure is a trapezoid, and the statement R, which is the figure has four right angles. So what is the truth value of that conjunction? The figure is a trapezoid and the figure has four right angles. So the second part, R, is true, but P is false. And so P and R is also false. Part B of example one is saying our tilde statement here in front of P, and then our caret symbol, and then Q. So a reminder of what that means is this is the negation of statement P combined with and then statement Q. So that means the figure is not a trapezoid, the negation, and the figure has four congruent sides. So not a trapezoid, that is definitely true about this figure over here, and has four congruent sides we can see from our tick marks surrounding that figure. Since both of those pieces of the statement are true, then not P and Q is true. Now we'll talk about disjunctions, which remember is this symbol of the upside down caret here. And we're talking about using the word or to connect the statements. So it says use the statements to write a compound statement for the disjunction P or not R, and then find its truth value and explain your reasoning. And again, we have three statements that we are to combine to find this disjunction. So statement P is that the angle ABC and angle CBD are complementary, and then we're combining that with or not R. So the segment AB and segment BD are not congruent. So what is the truth value here? P or not R is going to be false because P is false. Those angles are not complementary. If we were to look at them from the diagram, we can see they make a linear pair. So they are supplementary, not complementary. And not R, A, B, and BD's segment measures are, they have tick marks on them. So they are definitely congruent. And so we would say that that not R is false as well. A conditional statement is going to be a compound statement that consists of a premise, we call that a hypothesis, and a conclusion, which is going to be false only when its premise is true, but the conclusion is false. So here on page 162, we have lots of different examples of conditional statements and then related conditionals to them. So first of all, an if-then statement is a compound statement of the form if P, then Q. So here's an example over in the right-hand column. If it rains, then the parade will be canceled. So P and Q are the statements, and the symbols P and then an arrow to Q is read if P, then Q. The hypothesis of the conditional statement is the phrase that's immediately following the word if. And the conclusion of the conditional statement is the phrase that's immediately following the word then. So our hypothesis is the orange part, if it rains, and the conclusion will be following the word then, the parade will be canceled. Actually, I should say the hypothesis is just it rains, and the conclusion is just the parade will be canceled. We leave out the words if and then. So all we want to do when we think of a converse, we're going to form that by exchanging the hypothesis and the conclusion. So remember, our original statement was if P then Q. Our symbols are reversed. We have Q with an arrow to P, which we read if Q then P. And so we take that same example from previous slide here, and we say, if the parade is canceled, then it has rained. And if you're an honors student, we're also going to be talking about two more related conditionals. The first one is the inverse, and that is formed by negating both the hypothesis and the conclusion. So remember, our negating symbol is this tilde. So we have tilde P, which is an arrow to tilde Q, and we read that if not P, then not Q. So we keep the rain and the parade in the same order, but we negate them. If it does not rain, then the parade will not be canceled. And then the last type of related conditional, if you're an honors student, is going to be the contrapositive. That is formed by negating both the hypothesis and the conclusion of the converse. So we take the opposite and we reverse the order. That is, if not Q, then not P. So if the parade is not canceled, then it does not rain. So in example 3, we're asked to identify the hypothesis and the conclusion of each conditional statement. Statement A says if a polygon has 6 sides, then it is a hexagon. And statement B says another performance will be scheduled if the first one is sold out. You can see the sentence structure here is a little different. So for part A, we're going to underline the part following the if word. So a polygon has 6 sides, and then we will underline the part following the then word. It is a hexagon. Hypothesis, a polygon has 6 sides. Conclusion, that polygon is a hexagon. Statement B, another performance will be scheduled if the first one is sold out. So we're going to notice that the if actually falls further into the sentence, but the part of the sentence that follows if, which says the first one is sold out, is our hypothesis. Make sure you also relate to what one is referring to, and that means the first performance. So the hypothesis would be the first performance is sold out. And then our conclusion would be the start of the sentence that comes before the if, which is another performance will be scheduled. And I hope you're writing along with notes as always. If you've lost track at all, we are on page 163 here before we get to our check. In the check, we're going to do something similar, which is to identify the hypothesis and conclusion of each of these conditional statements. A, if the forecast is rain, then I will take an umbrella. And B, a number is divisible by 10 if its last digit is a 0. See if you can take a pause in the video and identify those hypotheses and conclusions. Okay, so sometimes we come across sentences that are not already in the if-then format, and we're just asked to transform them. So here in example 4, and I am on page 163, we're asked to identify the hypothesis and the conclusion for each of these conditional statements and then transform it into the if-then form. So the first one says 4 quarters can be exchanged for a $1 bill. And then B says the sum of the measures of two supplementary angles is 180 degrees. So part A can be broken down because you're starting out with 4 quarters. That would be your hypothesis. You have 4 quarters. And then the conclusion is what can you do with them? You can exchange them for a $1 bill. So if we put the if in front of the hypothesis and the then in front of the conclusion, we get a conditional in that format. If you have 4 quarters, then you can exchange them for a $1 bill. So here in part B, we're going to say what is the condition that we're starting out with, and that is that we have two angles that are supplementary. So we'll write that. Two angles are supplementary. And what can we do with those two supplementary angles? The conclusion would be that the sum of their measures is 180 degrees. So if we put those together with our if then, we can say if and then structure. If two angles are supplementary, then the sum of their measures is 180 degrees. So take a pause in the video here and see if you can identify the hypothesis and the conclusion of the conditional statement. A quadrilateral with two sets of parallel sides is a parallelogram, and transform that into if-then form. Okay, in example 5 on page 164, We are going to be talking about these related conditionals that we've been discussing. And so this is an example of some related conditionals found in the science of saltwater fish. So the tang is a saltwater fish that inhabits shallow coral reefs in tropical areas. And tangs are part of the Acanthuridae family. Let's see if my science teachers agree with that pronunciation, along with surgeonfish and unicornfish. So all the members of the Acanthuridae family are saltwater fish. So we're going to write the converse, the inverse, and the contrapositive of the true conditional statement. Tangs are fish that live in salt water. We're going to determine whether each of those related conditionals is true or false. And then if it is false, find a counter example. I like to think about the relationships here and to visualize it with a Venn diagram. So if you want to go off to the sidebar and take down what I mean here, a Venn diagram helps us to find relationships between groups of things. So first of all, we are told that the tang, so we'll put all of the tangs in their own little circle, is a saltwater fish that inhabits those reefs, and it is part of the Acanthuridae family. I'll just abbreviate it like so. But that so are the surgeonfish, a part of that family, and also the unicorn fish, a part of that family. Then we're also told that all of the Acanthuridaes are in general just saltwater fish. So this visual representation of the relationships can help us as we continue to write these conditionals and related conditionals. So the first related conditional we're going to find is our converse. And remember, a converse is going to flip the hypothesis and conclusion. Hypothesis being that the fish is a tang, conclusion that it lives in salt water. So we're going to start with, if a fish lives in salt water, then our conclusion is that it is a tang. So if we look at our visual over here and we try to figure out what is inside the saltwater fish that is not a tang to find our counter example, you can see why they picked surgeonfish. It's inside that big saltwater fish, but it's not a tang. And you could also find a unicorn fish that would be a counter example. So of course, our converse is going to be false. And honor students, let's go ahead and do the other related conditionals, inverse and contrapositive. So the inverse, remember, is the negation of the original condition. So if a fish is not a tang, then it does not live in salt water. And what counterexample can we find for that? Well, something that's not a tang but that does live in salt water would be a surgeonfish. Therefore, the inverse is false as well. And then our contrapositive, remember, is the negation of the converse that we found on the previous slide. So if a fish does not live in salt water, negation of the original conclusion, then it is not a tang. And based on the given information that we can see in the Venn diagram, a fish that does not live in salt water would be outside of this circle. And since tangs are inside of that circle, then we would say that that final contrapositive statement is true. Let's take a pause on the video and see if we can go through some related conditionals with a different world of conditional statements illustrated in the world of music. So our interrelated groups this time are that symphony orchestras contain instruments from four musical families: strings, woodwinds, brass, and percussion. However, string orchestras only contain string instruments. String instruments include the violin, viola, cello, bass, and harp. And now we're going to write the converse, the inverse, and the contrapositive of the true conditional statement that says if an orchestra is a string orchestra, then it contains string instruments. We're going to determine whether those related conditionals are true or false. And if false, you're going to find a counterexample. And a reminder that those last two related conditionals, inverse and contrapositive, are for honor students only. Our next learning goal is talking about biconditionals. So logic and biconditional statements are going to be indicating exclusivity in situations. So for example, Iran is applying for admission into culinary school, and he must earn a 3.5 GPA or higher this semester in order to be accepted. So you can express this as two if-then statements. If he earns a 3.5 GPA or higher, then he will be accepted. And if Iran is accepted into culinary school, then he has earned a 3.5 GPA or higher. So the logic is flowing in both of those directions. So when we see the symbol for, because we have a conjunction of the conditional and its converse, remember a conjunction is that word and, so both of those things are true, the conditional and its converse. We can say that if P then Q and if Q then P can be condensed into P and then a double arrow to Q, double-ended arrow there. And that is read P if and only if Q. So for this example, our biconditional statement will read, Iran will be accepted into the culinary school. Here's our phrase, if and only if he earns that 3.5 GPA or higher in the semester. So here in example 6, we're going to be writing some biconditional statements with the conditional and the converse separated first, and then determine the truth value of that conditional and converse. Then if that's false, you're going to find a counterexample. And if it is possible to write a biconditional statement, you will do that. So our first example, part 6a, is saying Rasha listens to music when she is in study hall. And then part B says if two lines are parallel, then they have the same slope and different y-intercepts. Let's see if we can pull these apart. So for our first statement here, Rasha listens to music when she is in study hall. The premise that she is in study hall comes first. So we say if Rasha is in study hall, and then comma, then she is listening to music. And we're asked, is the conditional statement true or false? And if false, you're going to provide a counterexample. In this case, we would say true. Although I'm not going to lie, you guys, my teacher mom self is hoping that if she's in study hall, she might be doing something else besides listening to music, like say her math homework, but we'll move on. The converse of that statement, remember, is going to flip that around. So we're going to say if Russia is listening to music, then she is in study hall. Forgive my kind of messy handwriting in this video. I'm trying to not have it go too long for you guys. Is the converse true or false? Well, in this case, I hope you would agree that it could be false because just because she's listening to music doesn't mean that she is necessarily in study hall, and you can just provide a different location to be listening to music. So could be listening elsewhere. So in her car, maybe at lunch, or maybe in her room, at home, lots of different places. So first we have true and then we have false. So because the converse is false, you cannot write a true biconditional statement. So now we say on part B, if two lines are parallel, then they have the same slope and different y-intercepts. Hopefully you can see that this is already in if-then structure, so I'm not even going to have us rewrite that as the conditional. It's just the same as what we have here. But our converse is going to interchange that hypothesis and conclusion. So we're going to start with if two lines, we're going to talk about the slope part first, have the same slope, but different y-intercepts. The then part will be that the lines are parallel. Well, the conditional and the converse are both true, so we could condense this into a biconditional. A biconditional can be written. And so we would say two lines are parallel if and only if, and then we'd say the part about the slope. They have the same slope and different y-intercept. Both the conditional and the converse were true. We can condense them into that biconditional. Go ahead and take a pause on the video and work on this check for example 6, where you're going to do the same as we did before. Write out the conditional and the converse for the statement you see below, and then determine the truth values of that conditional and converse. If they're false, find a counterexample, and if possible, write a biconditional statement. The statement is isosceles triangles have at least two congruent sides. Next, we're going to take a biconditional apart into its conditional and converse and determine whether the biconditional itself is true or false from those pieces. If it is false, give a counterexample. So the first here is two angles are complements if and only if their measures have a sum of 90. Remember, the statement on either side of if and only if become your hypothesis and conclusion. So we'll start off with the conditional statement from the biconditional. And so one way to do that, notice it says sample answer here. You could start either direction. We'll start with the same order it's stated. So if two angles are complementary, then their measures have a sum of 90 degrees. Conditional in that order, hypothesis, and then conclusion. So now the converse, we'll turn it around and we will say if two angles have measurements that sum to 90 degrees, then they are complementary. So let's go back and look at the truth values here. If two angles are complementary, then their measures have a sum of 90 degrees. That is true. If two angles have measurements that sum to 90 degrees, then they are complementary, and that is true as well. And so the conditional and the converse are true. So the biconditional is also true. This often happens when you have definitions. Go ahead and take a pause in the video as we take this biconditional apart into its conditional and its converse and determine whether it is true or false. If it is false, go ahead and give a counterexample. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. All right, we're going to go back to page 163, which is where our first check of this video was located. And here we are asked to identify the hypothesis and the conclusion of each of these conditional statements. So part A, if the forecast is rain, then I will take an umbrella. Remember, after the if word is where our hypothesis will lie, and after the then word will be where our conclusion will lie. So we will say here, the hypothesis is that the forecast is rain, and the conclusion is I will take an umbrella. The second conditional statement is that if a number is divisible, sorry, let me try that again. A number is divisible by 10 if its last digit is a 0. And here we again have if a little later in the sentence. So this part here would be my hypothesis. And that makes this part my conclusion. So our hypothesis becomes a number's last digit is a 0. And the conclusion is it is divisible by 10. I'm staying away from the orange text that I've been using for the checks in previous videos. Hopefully you can understand why, as we've been color coding our hypothesis as orange and our conclusion as green throughout. So didn't want to confuse you guys there. In our check for example 4, we are on page 164, and we're writing this conditional in if-then form. It says a quadrilateral with two sets of parallel sides is a parallelogram. So our hypothesis would be a quadrilateral has two sets of parallel sides. And our conclusion would be the quadrilateral, I'll abbreviate here, is a parallelogram. Putting that together into an if-then statement, we would say if a quad has two sets of parallel sides, comma, then it is a parallelogram. So in our music example, just like with our fish example, again, I think it helps to draw some Venn diagram that helps relate the different groups of items. So we have a symphonic orchestra, and inside of that symphonic orchestra, we have both string instruments and we have percussion, brass, and woodwinds. Within the string category, we have violin, viola, we have cello, we have bass, and we have harp. So now if we use these relationships to come up with the conditional and the related conditionals, and then determine whether each of those are true or false, we can use this Venn diagram to help. For the converse of if an orchestra is a string orchestra, then it contains string instruments. We will flip this around and say if an orchestra contains string instruments, then it is a string orchestra. So if we look at the work over in the Venn diagram here, we would say that this would be a false example because over here, this could be a symphonic orchestra, which contains string instruments, but it might not be a string orchestra. So it could be containing these other instruments, which contain non-string instruments. You want to write down your counter example. Try this again, different tool here. If you want to write down your counter example, then your counter example would be a symphonic orchestra. If you're an honors student, you also went and did the inverses and the contrapositives. So an inverse would be, remember the negation. So we would say if an orchestra is not a string orchestra, then it contains no strings. So we go over to our diagram and we say if an orchestra is not a string orchestra, well, then it could be, again, a symphonic orchestra. And therefore, since symphonic orchestras also contain strings, this would again be a false statement, and that the counter example would again be a symphonic orchestra. Then our final statement here for honors is a contrapositive. So we would negate the converse. If an orchestra contains no strings, then negate the last part as well. It is not a string orchestra. And that would be a true statement. Again, looking at it. If an orchestra contains no strings, so there are no strings in anything, then it is not a string orchestra. Very true. In our check for example 6, we are here on page 166. And we're asked to write the conditional and the converse from this statement to determine the truth values of those, and if possible, find a counterexample or write a biconditional if it is true. So isosceles triangles have at least two congruent sides. Let's go ahead and make that into a conditional and a converse. We could start off by saying that if a triangle is isosceles, then it has at least two congruent sides. Converse would turn that around if a triangle has at least two congruent sides, then it is an isosceles triangle. So this first statement, the conditional, if a triangle is isosceles, then it has two congruent sides. That's true. The converse, if a triangle has two congruent sides at least, then it is an isosceles triangle. That's also true. So here we have a definition that we can now write as a biconditional statement. The conditional is true, the converse is true. So the biconditional says a triangle is isosceles. Here's our biconditional statement. If, or phrase, if and only if it has at least two congruent sides. All right, our final check also on page 166 for example 7. We're taking the biconditional and writing it as a conditional and its converse, and then determining whether the biconditional is true or false. And if it's false, we're going to give a counterexample. So our statement says x is greater than -2 if and only if x is positive. First conditional would say if x is greater than -2, then x is positive. Our converse would flip that around and say if x is positive, then x is greater than -2. The biconditional here is definitely false because we could find a counterexample. For instance, x equals -1. In the conditional, if x was -1, that is greater than -2, but not an x value that is positive. So this would be false. And then the converse, if x is positive, then x is greater than -2. Well, all positive numbers are greater than -2. But remember, for the biconditional to be true, both the conditional and the converse have to be true. So the biconditional is false, and that would be x equals -1 is a counterexample. Well, there you have it for our work with statements, conditionals, and biconditionals. We will see you in the practice.